Good day to all. In this video, I am going to explain the IoT devices and building blocks of IoT devices and Raspberry Pi board details. Okay. Uh, the IoT devices, I think in Internet of Things can be any object that has a unique identifier. Okay. Each and every IoT devices having an unique identification. So every device is having unique identifications means we can easily access the devices and we can implement or apply any kind of applications. It's easy to identify for different kind of IoT devices. Okay, so unique identifier and which can send and receive data, including user data over a network, smartphones, smart TV, computers, refrigerators, cars, and etc. Okay. IoT devices are connected to the internet and send information about themselves or about their surroundings. Surrounding information sent by the connected sensors over a network to other devices or server storages or allow activation upon the physical entities environmental around them remotely. Okay. So our surroundings we can implement or applying the any IoT applications means more number of sensors are deployed and equipped with different areas for in our surroundings. These sensors are collected many kind of information or data and sent to the one cloud areas or any other storage cloud storages via the wireless network communications. Um, and then based on the collected information or collected data, the programs will be accessed, take the action of actuator, any one of actuators like them, it will be on or off conditions. It will be controlled by the IoT devices. Okay. This is the basic building blocks of one IoT devices. Each and every IoT devices having these entities. The first one is connectivity. The USB host connectivity and Ethernet connectivity will be there, and processor and graphics card will be there. CPU central processing unit and graphical processing unit. Okay. In Raspberry Pi board, it's not having on GPU boards. It's only having on CPU. If you are taking the NVIDIA A processor means that's having on GPU. GPU means it will be applied for the large applications. CPU means it's only having on CPU means it will be applicable for the small kind of application. Okay, and also it's having an audio video HDMI, RCA video connectors and interfaces. Many of the communication interfaces, UART, SPA, and ITC CAN communications will be there. UART means universal asynchronous receiver and transmitter. SPA means serial programmable peripheral interface and the computer area network. SD means secure digital and MMC multimedia connector, serial secure digital input and output devices. These are all the memory storages systems. These are all essential for any kind of IoT devices to make them complete. Okay. So this is a physical layout of the Raspberry Pi board. In Raspberry Pi, it's one of the processors. It's running on all these entities, all the ports are available. The first one is USB port, it's having an USB port, it's having an Ethernet port, and it's having on CSA connector and DSA connector, display connector, and a camera connector. Okay, separately it's having. And then one micro USB power supply will be there, a slot will be there, HDMI cable connector will be there, and also video GHS LEDs will be there. In one small computers, that computers, what are the peripherals will be there and having means this all the connected ports and the peripherals will be available in a Raspberry Pi board. Okay. It's working on Linux OS and Raspbian OS Linux platform. Okay. We can having on 16 GB or 32 GB SD card means can mounted or write the OS for in this card, and then the card is inserted into the slot. The green color LEDs will be glows, means the Raspberry Pi will be properly working, and red color LEDs means it's not properly working. Any of the faults will be there, like writing of OS or any other kind of problems will be there. Okay, so this is the status of LEDs will be there for the status of working of Raspberry Pi boards. These are all the Raspberry Pi GPIO headers. Two 5-volt ports will be there and one ground. And GPIO 14, 15, 18, and all the GPIO boards will be used as input and output ports. And also GPIO 14 and 15 are transmission received protocols, communications, IoT Universal Reference Receiver Transmitter protocols will be there, 14 and 15 pin. And GPIO 2 and 3rd pin we can use for I2C communication protocols. GPIO 9 and 11 will be used as a SPIO, and 8 and 7 also used as a SPIO communication protocols will be there. Okay, and 2 3-volt port will be there in Raspberry Pi GPIO headers. Okay, it will be working different kind of Linux OS, Raspbian, Arc, PIDO, ROS, PMC, OpenALEC, RISC OS. It will be operated in different kind of OS operating systems. Okay. Okay, this is a general layout of desktop of Linux Raspbian. Okay, this is the file explorer on Raspberry Pi, the console of Raspberry Pi. Okay, these are all the settings of Raspberry Pi configurations. These are all the Raspberry Pi interfaces. So Raspberry Pi is having on serial, SPI, and I2C communications will be there. The serial communications interfaces Raspberry Pi has receives and transmitter pins for communications with serial peripherals. SPI means serial peripheral interface is a synchronous serial data protocol used for communicating with one or more peripheral devices. In an SPI connection, there are 5 pins on Raspberry Pi for SPI interfaces, and also it's having on I2C communications also available in the Raspberry Pi. These are all the peripheral interfaces for Raspberry Pi systems. Okay. So next, programming of Raspberry Pi with Python. In this topics, how to explain for the next. Thank you.